Welcome to Study Loop.
Okay, so this question is about axon, that is conducting a nerve signal. And now, how it works is transferring the ions across the cell membrane. And the question says that the current density in the cell membrane, let me write that here, that is I upon A. The current density in the cell membrane is 5 milliampere per cm squared, right? Now, when the voltage across the membrane is 50 millivolts. Now the question is asking what is the number density of open ion channels? So how many channels are there? Suppose there are n channels, all right, n channels, each of resistance R. Okay. Now since the channels are in parallel, so the equivalent resistance Req would be R by N, right? Okay, so now what we can do is use the formula I by A equals to, well, I by A, I equals to V by Req, right, the current. Now what I want to do is substitute the value of Req here. So V upon R times N, right? Now what I want to do is divide by A on both sides. So I by A equals to V into V by R into N by A. So here the number of channels per unit area, this is what we need to determine. Number of channels per unit area. So N by A will be equal to how much? I by A into R by V. Now you know the value of I by A, that is 5 milliampere per cm squared. Okay, let me not write that here. Okay, I should write because I need to cancel it from numerator and denominator. And what about R? It is not in this question, but in the previous question, the resistance is given as 10 to the power 11 ohms, right? Upon A is done with I. Now what is V? 50 millivolts. Now milli cancel out and ampere ohm cancel out. Ampere ohm cancel out with V, right, voltage. So what we are left is equal to 10 to the power 11 per cm squared, right? So our options there, which one is matching with this? Okay, so we need to convert this. So okay, this should be equal to 100 micrometers, 100 per micrometers. So these many number of channels are there in 1 unit area of the membrane. So this ends the solution to this question. Thank you for watching.